Okay. Welcome to Pratik Academy. From this video, we are starting a short video series on subject noise and vibration. This video series will consist of theory and some sample numericals related to this subject. This video series will helpful for final year subjects for understanding concepts related to vibrations. So let's start. Okay. First, vibration. What is vibration? So simply it is defined as to and fro motion of body about a mean position. Then the motion is called as vibration. That is, suppose this is the mean position of body. When body moves to and fro about this mean position, then body is said to be performing vibrations. Okay. Another definition is that a motion which repeats itself after equal interval of time is called as vibration. That means a body which repeats itself after equal interval of time is said to be performing in vibration. Okay. Examples of vibration, classical examples is pendulum. Okay. When we attach a mass to string, it example of pendulum. When there is no any external forces acting on pendulum is at in vertical position. If it deflects this mass by small amount, then it will start to oscillate about this main position. So pendulum is said to be performing in vibration. Another classical example is spring mass arrangement. Okay, when we attach mass to spring, it deflects by some amount. Then when we move this mass by some downward direction and release this mass, then this mass will continuously move in upward and downward direction. So it is in vibration. Similarly, if you take a rotor which is attached to a shaft, and if we twist this rotor by some amount and release, if it is this shaft by some amount and release, then it will start to move about this main position in this direction, in this way. So it is again example of vibration. Okay. All the bodies which is having mass and elasticity are capable of performing vibrations. Okay, so this is vibration. Then next is, what are the reasons of these vibrations? Okay. First reason is external excitation. When some external force is acting on system and release, then it will produce unbalance in system and it will cause for vibration. When earthquakes and winds are again responsible for vibrations, then unbalanced force in system is responsible for vibration. Then again dry friction between two bodies is are the reasons for vibration. Then what are the effects of vibration? First effect we will see that are harmful effects. So when there is vibrations, it will produce noise of noise. So it generates, no, vibration generates noise, so it is harmful effect. Then it is also responsible for loosening of parts of machine, so joints becomes loose. So this is again harmful effect of vibration. Next is, it will cause partial or sudden failure of system due to vibration. So these are the harmful effects of vibration. Then there are some useful effects of vibration. We know that sound is produced due to vibrations. So this is the one good example, or this is the one useful effect of vibration. And next is musical instruments. We are producing vibrations, and due to vibrations of different frequencies we hear different sound notes. Then again, one regular example is vibrating hammers, which are used in road construction. They vibrates to their vibrations are useful for construction works of road. Then stress relieving. Okay, vibrations are usually for stress relieving purpose also. Okay, these are the some good effects of vibrations. Then when vibrations are harmful, then we have to reduce that vibrations. And what are the ways of reducing that vibrations? First method is to remove external cause responsible for vibration. Then our body or system becomes stable. Then next reason or method is to balance forces in system. If there is any imbalance in system, then we have to remove or balance that unbalanced system or unbalanced mass, so that system is become balanced and vibrations are removed. Then next is providing dampings and shock absorbers. This absorbs shocks, and this absorbs energies of vibrations and reduces vibration. Then providing dynamic absorbers. We will see what is absorber in next topics. Then next one is a resting system on proper isolation. That means isolate system from cause of vibration. We will discuss this later, but at this stage just remember that vibration isolator means isolated system, vibrating system from cause of vibration. So these are the methods to reduce vibrations. Then we will see some basic definitions required for vibrations. So first definition is product motion. As we know, a motion which repeats itself in equal interval of time is called as product motion. Then second one is a cycle. Cycle is a pattern in motion which repeats itself again and again. That means if there is a sine wave, then this pattern is repeating after equal interval of time or again and again. Then this pattern is called as one cycle. Okay. Then time period. Time period is the time required to complete one cycle. It's called as a time period. It is denoted by T. Okay. Then what is frequency? Frequency is number of cycles completed per second. It's called as frequency. Then the relation between frequency and time period is frequency is equal to 1 upon T, and its unit is hertz or radian per second. Then amplitude is maximum displacement of a body from its mean position, is called as a amplitude. Then next one is a natural frequency. Natural frequency is a frequency with which body is vibrating when there is no any external sources are acting on system. That means body is vibrating with its own or system characteristics, and it is constant for given system. The next one is a forced frequency. It defined as frequency of system when it is acted upon by external forces. It is called as a forced frequency. Now, next definition is a resonance. Resonance is a situation when resonance is a situation when forced frequency is equal to natural frequency. When force frequency is equals with natural frequency, then it is called as a resonance. Then damping means resistance to vibration. Damping absorbs or removes energy from system, and hence they are opposing. In this way they are opposing or removing vibrations. Okay, then next is important is degree of freedom. Degree of freedom is defined as number of independent parameters required to specify configuration of system at any instant. It means when we say single degree freedom, then only one independent parameter. Suppose this is the spring mass system. Okay, then by telling only deformation in spring, we can specify configuration of this system at any instant. For this pendulum, when we specify only this theta, then at any instant when we give value of theta, it will completely represent configuration of system at that instant. Suppose there are two pendulums here, then to specify this system we have to give two values of theta, theta 1 and theta 2 here. Then this system becomes 2 degree freedom system. Okay, similarly for here, if there are two springs, then we have to specify deformation of spring K1 and spring K2. Then this will be 2 degree freedom system. Then next is simple harmonic motion. What is meant by simple harmonic motion? The simple harmonic motion is a motion in which acceleration is proportional to displacement of body from its mean position and is always acted towards mean position, that is opposite to displacement. Then motion is called as simple harmonic motion. Next one is a next important is a phase difference. What is phase difference? It is the angle between two rotating vectors representing SHM of same frequency. It means if frequency of two vectors are same, then angle lag between these two vectors or angle lead between these two vectors is called as phase difference. Okay. Now next point is parts of vibrating systems. So basic parts of system, we require one support. Okay, then one element is spring, another one element is damper, next element is a mass. Okay, this represents excitations or excitations or movement of this mass. Okay, so when mass is displaced from its mean position, then energy is stored in mass is a kinetic energy due to its motion. Okay, then energy is stored in spring. When we deform this system from its mean position, spring gets deformed and this deformed energy is stored in spring as a strain energy or potential energy. Okay, then third element is a damper. Damper opposes motion of body and brings system to rest. That is, in dampers, energy is dissipated. So these are the three important parts of system. Spring and mass are energy stored element, and damper is a energy dissipating system. Now let's see how vibrations or how system executes vibration. So consider this diagram. Consider a spring mass system. Spring is having stiffness, suppose K, and block of mass is say M. And at equilibrium position, system is at rest. Now when we pull this mass by small amount x, then when we pull this mass, then spring gets deformed, and against this spring stored energy in form of strain energy or potential energy, and spring force is acted in upward direction opposite to deformation. When we hold this mass, then it is not having any velocity, and all energy is stored in form of strain energy in this spring. When we release this mass or remove external force, then this strain energy tries to move this mass to upward direction. When mass starts moving, it acquires velocity. Then at equilibrium position or original position, all deformation is zero, that is strain energy is zero here, but due to velocity mass is having kinetic energy, and due to this velocity it will move in upward direction. Then it will move in, when it will move in upward direction, spring again start to oppose this deformation, and energy is stored in form of strain energy. When at extreme position, when velocity is zero, then strain energy is maximum due to maximum deformation, and spring force tries to move this mass in downward direction. Then again in extreme condition, there is no any velocity, so kinetic energy is zero. It is having only strain energy or potential energy, and due to this spring force, mass is moving in again equilibrium or mean position. When it comes to mean position, it is again having velocity, and due to velocity it will move in upward direction, sorry, opposite direction, and this cycle continues again and again. It means at extreme condition it is having strain energy and kinetic energy is zero. At equilibrium, strain energy or potential energy is zero and kinetic energy is max. Again in upward direction, strain energy is max and kinetic energy is zero. So due to these energy interactions or convergence, vibrations are taking place continuously. If there is no any vibration, if there is no any resistance to this motion, then system will start continuously performing vibrations. So these are all about vibration. In next video we will see types of vibrations and prove why or prove vibration as a session. Thank you for watching. If you like, please subscribe our channel. Thank you.